Alright, we're going to look at quadratic inequalities. So, first thing we're going to talk about is writing the solution to the given graph in interval notation. So now we're going to have two parts. So the way that we have two parts, we just put a U in between, which means and. So that's all that is. It doesn't mean anything fancy, it doesn't mean anything confusing, it just means we have two parts. So, again, I can get my pen going. U means and. So my answer here is from negative infinity to negative 3, not including it, so that's why I have parentheses. Union, so and, 4 to infinity, so 4 to infinity, including 4 because it's shaded in, but parenthesis on infinity because we always have parentheses. Same thing with number 2, negative infinity to negative 5, not including negative 5, and 1 to infinity, we include 1, so it's a square bracket. Number 6, same thing, negative infinity to negative 8, parenthesis on the negative 8, and negative 3 to infinity, bracket on the negative 3, because it's shaded in. Then 4, 5, and 6 is what we're used to. Our answers are from negative 4 to 4, so negative 4, comma 4, bracket on the 4, parenthesis on the negative 4 because of what's shaded in. Same thing now, number 5, it's negative 4 to 6, parenthesis on the negative 4, bracket on the 6. And then number 6 is negative 10 to negative 4, so bracket on both because they're both shaded in. So that's how we write our interval notation. And we have two parts, we use the U to mean and, if we have two parts to our answer, which we're going to have sometimes. Alright, so now we're going to shade the correct part of the number line and write the answer to interval notation. So we have the equation, I even gave us the zeros, so there are the circles, and we have to figure out where we have to shade. Well, what we do is we test numbers. So I picked negative 11 because that's to the left of both numbers, 0 is in between, and 2 is to the right. So we have three sections. These two solutions split up our number line into three sections, so we're going to test three sections. So we plug in negative 11, we plug in 0, we plug in 2, and we see which is right. So negative 11, when we plug in, it gives us 23. 23 is not less than 0, so that's not right. If we plug in 0, we get negative 10. Negative 10 is less than 0, so that's right. That's a check mark. We plug in 2, we get 36. 36 is not less than 0, so that doesn't work. So negative 10 or 0 is our answer, so 0 is where all our answers are. So it's in between the two sections. So how do we write the interval notation? From negative 10 to 1/2, because that's what those zeros are, and they're both parentheses because they're open circles. Number 8, our zeros are at negative 8 and 4. Again, we could have factored, we could have used a quadratic formula, we could have completed the square, but I gave us the solutions. And that splits it up into three answers. So I chose negative 10 to the left, I chose 0 in between, and I chose 5 on the right. Wherever you can, choose 0 because that's the easiest. So I plug in negative 10, I get 28, which is not less than 0, so that's an X. I plug in 0, I get negative 32. Negative 32 is less than 0, so I get a check mark. That works. I plug in 5, I get 13. 13 is not less than 0, so I get an X. And so my answer is where 0 is. So that's in between again, so I shade in between. So it's from negative 8 to 4, parentheses, because they're both open circles. Again, the reason we're shading in between is because x equals 0 worked. X equals 0 is in the middle, so that's why we're shading in the middle. Here, number 9, we have zeros of negative 4 and 1/3. We can't quite tell, so that's why I wrote it out. And we substitute in, I picked negative 5, always choose 0 because it's easy, and then 2. So negative 5 gives us 16, which gives us the left side. 16 is not less than or equal to 0, so that's no. So those X's really mean no, and the check mark means yes. 0, when you plug it in, you get negative 4, which is less than 0, so that's a yes. I plug in 2, and that's a no. So these are all no's, these are all no's, all my yeses are in between. So it's from -4 to 1/3, and now they're shaded in because it's less than or equal to, so we have square brackets. So square bracket on -4 and square bracket on 1/3. Last one. So we have three sections again, -3, 0, and 10. Even though my zeros are decimals, I choose whole numbers to plug in. Plug in -3, I get 17, which is greater than or equal to 0. So that's a yes. I plug in 0, I get -10. -10 is not greater than or equal to 0, so no. And then I plug in 10, I get 30. 30 is greater than or equal to 0, so I get yes. So I have two yeses, so I have shading outside the region. So I have two parts to my answer. So it's from -infinity to -1.4, and so the U, 7.4 to +infinity. And since they're shaded in, I have brackets on the -1.4 and the 7.4, but I can never have brackets on the infinity or -infinity. So this is what my answer looks like. So now we're going to put it together and do full problems. So here I also wanted us to use each method only once, so we get practice. So this first one, I decided we were going to use the quadratic formula. So to do that, we have to set it equal to 0 first. So I have to subtract 25. So I get 3x squared plus 10x minus 25 is less than 0. So I plug it in. Negative b plus or minus b squared minus 4 times a times c all over 2 times a. So -10 plus or minus 10 squared is 100. -4 times 3 times -25 is positive 300 over 6. -10 plus or minus square root of 400 is over 6. Square root of 400 is 20, so I can actually do it. So I get -10 plus 20 over 6, -20 minus 20, or -10 minus 20 over 6. -10 plus 20 is 10 over 6 is 5 over 3, so we get a fraction, and that's okay. -10 minus 20 is -30, divided by 6 is -5. Those are my zeros. So they're here and here, and they're open because it's just less than. So now I need to test a number. Now really, I only need to test one number. What number is the easiest to plug in? 0. So I plug in 0. And I plugged it into my original inequality. So 3 times 0 squared plus 10 times 0, and when I want to see if it's less than 25. Well, 0 squared is 0 times 3 is 0, plus 10 times 0, which is 0. So is 0 less than 25? Yep. So that means x equals 0 is a solution. So wherever x equals 0 is, that's where my answers are. Well, x equals 0 is in between, so my answers are here. So I really only need to check one number. So my answers are from -5, because that's the lowest number, to 5 over 3, that's here, and they're parentheses because they weren't shaded in, and that's it. So -5, comma 5 over 3, parentheses. And I used the quadratic formula here. Number 12, I decided I wanted to factor. So again, I have to set it equal to 0. So I subtract 24 from both sides, and I add 4x to both sides. So I get x squared minus 2x minus 24 is greater than or equal to 0. Then I do my diamond problem. 1 times -24 is -24. Bottom number is -2. The two numbers that work are -6 and -4, or positive 4. But because a is 1, I can skip right to here. So it's x minus 6 and x plus 4. I guess I don't really need these x's because I'm using my shortcut because a is 1. So x minus 6, x plus 4. I set both those equal to 0. Here I add 6 to both sides, x equals 6. I subtract 4 from both sides, x equals -4. So my zeros are at -4 and 6. And they're shaded in because this is shaded in. So I shade them in. And again, the only number I really need to check is 0. So I substitute in 0 and I went back to the original inequality. 0 squared minus 6 times 0, greater than or equal to 24 minus 4 times 0. Well, over here, 0 squared is 0, minus 6 times 0 is 0, so I get 0. 4 times 0 is 0, so all I have is 24. Is 0 greater than or equal to 24? Of course not. So, wherever x equals 0 is not an answer. Well, x equals 0 is in between here, so that's not an answer, so my answers have to be outside of them. So I have two parts to my answer. I have negative infinity to negative 4, that's what I have here, and I have a bracket on the negative 4 because it's shaded in. The u means I have two parts, so and. It starts at 6 and it goes to infinity, and again it's a bracket because it was shaded in. So this is my answer. So that was my factoring method. Here I'm going to use the square root property because I don't have an x term. So it's kind of obvious that I have to use the square root property. So I subtract 10 from both sides. I get negative 4x squared is less than negative 64. Then I divide by negative 4. Notice when I divide by a negative number, I flip the inequality sign. So I get x squared is greater than 16 now. Then I take the square root to get rid of this squared. Oops, that shouldn't be there. So I get x is greater than or equal to plus or minus 4. So 4 and negative 4 are my answers. Well, I still need to test where my answers are, and they're open because it's just less than. So again, I tried x equals 0. That's all I need. I plug in 0. I get 10 minus 4 times 0 squared. And I want to see if it's less than negative 4. Well, this just gives me 0. So 10 minus 0 is 10. Is 10 less than negative 54? Of course not. So x equals 0 is not my solution. X equals 0 is in the middle here. So my solution has to be on the outside parts. So I have two parts to my answer. I have negative infinity to negative 4, oops, negative 4, and I have 4 to infinity. I put the u in the middle to say and I have parentheses because they were open circles. So that's my answer. One last problem, and I have to do this by completing the square because I did all the other methods. So I have to set it equal to 0. Actually, I don't need to set it equal to 0, but I do need to get all my x terms on one side. So I subtract x squared. So I get x squared minus 19x plus something is less than or equal to negative 84 plus something. So I do negative 19 divided by 2. Oh, I can't get a whole number there, so I keep it as a fraction. Then I square that, and I just square both parts. 19 squared is 361, 2 squared is 4. And it's positive, because anytime I square something, I get a positive number. So I'm adding in 361 over 4 to both sides. Now when I do that, on the left, I have x minus 19 over 2, because that's this. That's this. So I don't need to factor it, because I can't factor these fractions. And I add on the left, negative 81 plus 361 over 4 is 25 over 4. So to get rid of this square root, I have to take the square root. So I get x minus 19 over 2 on the left side. And over here, well, I can take the square root of both of those. Square root of 25 is 5, and square root of 4 is 2. So I could actually take the square root of that, even though it was a fraction. Then I have to add 19 over 2 to both sides. So I get 19 over 2 plus or minus 5 over 2. Again, don't forget the plus or minus whenever I take the square root. So I get x is less than or equal to 19 over 2 plus or minus 5 over 2. So I do 19 plus 5 over 2 and 19 minus 5 over 2. Well, 19 plus 5 is 24, divided by 2 is 12. 19 minus 5 is 14, divided by 2 is 7. So my answers are at 7 and 12. And then again, I try a number, and the easiest number is 0. So I plug in 0 to the original inequality. 2 times 0 squared minus 19 times 0 less than or equal to negative 84 plus 0 squared. Well, this whole left side, this equals 0, this equals 0, and 0 minus 0 is 0. Over here, 0 squared is 0, and I have negative 84. Is 0 less than or equal to negative 84? Of course not. So x equals 0, not a solution. So wherever x equals 0 is, those are not answers. Well, x equals 0 is here. So that means this is not my solution. That means my answers have to be in between the two. Because this would be no, this would be yes, and this would be no. So my answers go from 7 to 12, brackets, because it was less than or equal to, and it's just one part, so we just write them as that one solution. And I've used all 4 methods.